Okay, let's move on to our second part about factoring, which is going to be factor by grouping. Again, the idea about factoring is to try to write a polynomial as something times something. So we're going to jump in right into an example. So what if I were to give you an example that said factor, and the polynomial we have is x cubed plus 5x squared plus 3x plus 15. Now what we learned before was always talk about greatest common factors. Is there something that we have a greatest common factor that we can factor out? That's always a good place to start. So we look through all of our terms. We notice we have 4 terms: x cubed, 5x squared, 3x, and 15. It looks like none of them have an x in common, and it looks like even between all of them there's no factor that's actually in common between all of them. One thing that you might want to think of is certainly this 3 and 15 have something in common. They have a 3 in common, but there's no 3 in common over for the other of these two terms. So that's always something you want to think about. It looks like there's no greatest common factor. However, there is another method, and that's this factor by grouping. So we're going to go ahead and look at the first group and the second group. And that's what I mean by factor by grouping. You have 4 terms, you're going to break it up. Look at just the first two. Just those first 2 terms. X cubed plus 5x squared. Is there a greatest common factor? Well, it doesn't look like there's a number in common, but definitely an x squared. Absolutely. So there's an x squared in common, and what do I have left over from that? I started off with x cubed. I took out an x squared, so there's an x left over, plus I had a 5x squared. I took out the x squared, so that's just the 5 that's left over. So that's the first group. You're, again, looking at this just one group at a time. Can you factor that? Now let's look at the second group. Positive 3x, positive 15. Is there something in common? Absolutely. There's a 3 in common. There's definitely a 3 in common. There's a positive 3 in common, so let's get used to actually writing that positive 3. And what's left over is then the x plus, well, if they started with 15, I took out the 3. That means you divided by 3, and there's your 5. So what we've done next here is I have now broken up my entire 4 terms into 2 separate groups. Then we can identify things a little bit nicer. Let's go ahead and look now what's in common. Can you guys see that there is an x plus 5 in common? In parentheses. It's that set of parentheses that's definitely in common. So now that I have that in common, we're going to factor out that x plus 5 as if it were the greatest common factor. So the x plus 5 is written once, and then the big set of parentheses for the what's left over. So the what's left over in this case, if you're looking at, you've already taken out that x plus 5, there is an x squared and a 3. That is what's left over, because each of them had the x plus 5 in common, so each of them separately, what was left over, that was the x squared and the 3. So what I have done is I have now written this as something times something. So that is a way of factoring right there. So that's a great way. Factor by grouping works a lot anytime you've got 4 terms. If you don't see any other way to factoring, this is another method that might be worth trying. Let's go ahead and do another example just for practice. Let's call this example 2 for this video, another factor by grouping. Same idea. I'm going to ask you to factor, and I'll give you the example: 2xy minus 3x minus 4y plus 6. Same idea. Let's think about it. Do I have a greatest common factor? There's not an x in all of those terms. There's not a y in all of the terms. Is there 2 in common for all of them? It looks like there really is close to being a 2, but 2 doesn't divide into 3, so that one doesn't work. So we're going to do the same idea. Let's see what we can do about factor by grouping. Let's break this up into 2 separate groups. Let's look at just the first group, 2xy minus 3x. Is there something in common? Well, between the 2 and 3, there's no number that divides evenly into both of those except for the number 1, but there's definitely an x in common. If there was an x in common, again, looking just at that first group, what's left over? If I took out this x, there's definitely still a 2 and a y left over, minus. Took out this x, there's definitely a 3 left over there. Okay, that was the first group. Now the second group. I have negative 4y plus 6. Now be really careful with this one. That negative is attached to that 4. Even though it doesn't look like it when your first instinct of how you group things, but you just need to be really careful. That negative really is attached to that 4. You can't get rid of it. So I have negative 4y plus 6. Do I see something in common? Definitely a 2. There's definitely a 2 in common. Now keep in mind what we worked with in the last example. I wanted at the end this parenthesis to match what's going to come next. So I wanted this to be the same. That's a positive 2. This over here is a negative 4. So if I decided to factor out a negative 2, that would turn into a positive 2y. I factored out the negative, so that gave me the positive. And then I took out a negative 2. What's 6 divided by negative 2? Okay, that's going to give me the negative 3. And again, always check. Sort of just kind of check in your head when you're working on these really quick. Quickly distribute that and just see if that works. Negative 2 times 2y is 4y. Check. Negative 2 times negative 3 is 6. Check. Just making sure that those match, okay, because they definitely do need to match. Oops. Okay. Alright, so what we've got so far is we've done this factor by grouping. The next step then is to look at see if there's anything in common. Is that parentheses the same? Are they matching? Absolutely. 2y minus 3 and then a 2y minus 3. So now I have that in common. 2y minus 3 is now my greatest common factor. The next set of parentheses is what's left over. So the what's left over is the x and the negative 2. So that is my final solution. And just as a reminder, what I want you guys to do now is go ahead and stop this video once you hear this and check. You need to check your work. How would you check your work? You would FOIL. Once you FOIL this answer out, you better have gotten the original question back.